So hello everybody, I'm Marcus, I'm a professor here at Texas A&M University, and today we're going to talk a little bit about applications, uninstallers, and removers. So I'll first talk a little bit about what are uninstallers, why studying them matters, and then we dive into some results. So first of all, how did we get here? So in the previous papers, I investigated the security of applications installers. Applications that are designed to install other applications in your system. So these applications are often downloaded from internet repositories that you can go there to some website, search for these applications and download these kind of installers. What we discovered is somehow staggering because we identified that some of the applications are Trojanized, some of the applications perform very deep modifications in the system, like setting proxies. Some of the applications are vulnerable to attacks, including like man in the middle, like that allows you to completely change the payload that is installed in the machine. And I noticed something very curious, that's basically that significant part of the applications distributed in these repositories are in fact uninstallers instead of installers. So they were designed to remove applications. So you might have been wondering, what are an uninstaller? And an uninstaller is an application like this that basically enumerates all software installed in your system and allows you to remove the software when you click. And then when you select the software, it's removed the software from your system. You might also be wondering, why does one need this kind of software once they have the native uninstallers and even the native Windows uninstaller designed exactly for this function? It happens that sometimes one cannot remove the software from the system. Sometimes the native installer that's shipped with the application fails to remove the software. And if you go to some websites, like the developers of the installer, as you can see here an example, but also to some popular web pages, web forums, blog posts, you can see many devices of one saying, oh, you should install a remover to remove this protected software, this non-compliant software, this software that's the typical installer, the native installer, or the Windows installer is not able to remove. So they are using this kind of stuff. You might also have been wondering if it really happens, and you can see here an example that we designed to show that it's kind of easy to develop an uninstaller that does not remove, that breaks the uninstallation. So the Windows uninstaller, as you can see here, is unable to remove this application. You can do that by mistake, it's a bug in the installer, or you can do that on purpose, as we did to demonstrate here, but could also be an attacker creating an installer that's never installed the application. And Microsoft also knows that it's possible to do that. Microsoft already summarized in the past, as you can see here, some typical reasons for why an uninstaller can fail and one cannot uninstall the software from a system. But we are most concerned here in this presentation, in this paper, about the malicious case. When an attacker develops an uninstall on purpose to not be removed from the system, to fail its installation. So we are concerned if these removers, if these uninstallers are effective on handling these malicious software installers and uninstallers. To present this, to answer these questions, if they're effective or not, we basically created a set of research questions that we present in the paper, we formalized in the paper. I'll skip the details and I'll tell you basically a summary that what we are trying to do here in this paper, in this presentation, is to understand how these uninstallers and removers are constructed, how do they work, if there are any difference between these installers and the native Windows uninstaller, why should one use these and not another one, if they should, and how effective they are in handling malicious construction, malicious uninstallers that on purpose will tamper with their operation, that will not remove themselves properly. To do that, we'd like to present a representative view of the uninstaller. So what we did was basically to revisit this previous paper on installers. Basically, we select the same popular repositories, we ranked the applications, we select the top 10, top 20 most popular uninstallers, and we presented an overview of what happens in these uninstallers. So these uninstallers are installed each one in thousands of machines, so we believe we present a representative view of users are most likely to have in their machines. So going to the results and present what we discovered. First, the anatomy of the uninstallers, how they operate. And basically what we can discover is that most uninstallers are in fact very simple. They are often standalone, executable standalone process that do all the operation by themselves in this executable. They include a few libraries when they included. In most cases, did not include libraries. In most cases, did not include kernel drivers to help them. And in most cases, did not have even configuration files or databases. In most cases, what they have is basically hard-coded configuration. A popular development strategy is to hard-code in these binaries, in this standalone software, block lists of popular and known adware software, that the softwares you look for in the file system or in the registry tree to be able to remove the software. So we can start hypothesizing right now that maybe these installers and remover are in fact much less powerful than we initially thought, or less powerful than initially advertised. But we'll confirm that later. What we also discover is that in some cases, these uninstallers are bundled with other applications, like games, advertisements, and other form of monetizing the software and make profit from that. So what happens is that the user is installing this remover to have less software in the computer, to remove some software, but what happens in fact is that in the end, the user ends up with more software installed in the system than it had previously when it was trying to clean the system. So it's a problem with all that kind of installers downloaded from repositories, include the removers and uninstallers. In terms of their operation and removal capabilities, what we discover is that in most cases, what these uninstallers do is to enumerate the installed application in the system the same way that the Windows application does. It basically, they use the same list. There's no advantage on that. Only a minor part of these removers have some other alternative way to search the file system or to search the registry tree to find the evidence of other software installation. In most cases, they just display the same list of installed applications of the Windows native uninstaller. More than that, we discover that for basically all applications, what they do is to first invoke the native uninstaller of the application. They do that in all cases. So when you're trying to remove an application, these removers, you first locate the native uninstaller of that application, run that native uninstaller, and only after that perform some cleanup routine. So only after that, they check if there are remaining files, remaining registry key, or any other remaining artifact in the file system or in the registry, and then try to clean up them. In most cases, that's just that what is performed. In a minority of cases, there are some heuristics to help in this procedure. So let's talk a little bit about the effectiveness of these heuristics. So basically, what we discover about this heuristic is that the way they work, it's basically they follow the path pointed by the native uninstaller and then remove whatever is in this path. So they check where the native uninstaller binary was located and remove that folder from the file system. It checks which registry key were pointing to that binary in the registry tree, and it removes all these registry entries. The problem is that it blindly trusts this information to perform these heuristics. So in the case of a malicious uninstaller, these heuristics will remove whatever the malicious uninstaller points to. So if the malicious uninstaller points to a third-party application located in a completely different location than the actual software to be removed, these heuristics will go there and remove, will delete files, will delete registry keys associated with the third-party application. So you cannot trust these uninstallers and removal to handle malicious uninstallers. Well, more than this removal capability, what we discovered is that these uninstallers are very good at present a better user interface than Windows native uninstaller. They are able to rank applications that are installed in your system based on a myriad of criteria, such the most frequently used files, the most large file size of the applications, the most updatable and the less updated software in your system. So they are able to rank applications and suggest removals of applications in those block lists hard-coded in the binary. They are able to present the information in a better way. So maybe this is the reason why some people are using this kind of third-party uninstaller instead of the native Windows uninstaller. Another difference that we notice is that these uninstallers have an extra feature of checking point installation. So they have the ability to create create snapshots basically before and after the installation of a software. So basically, this is a way to inform the remover about the files that change between the clean system state and the installation of a software. So in the future, when we request the software to remove a given application installed by that time, it knows which files to remove. The problem is that this is kind of heuristic as well. Basically, this information, the information used by these installers to remove the applications is the timestamp. It does not create a hash of the file. It does not check the content of the file. So if the installer is malicious, the installer will touch files not related to its own installation during the installation process, only to add these files to the snapshot. So in the future, when you regret of installing that software and you want to remove the software, when you run this checkpoint-based installation procedure, what will happen is that it removes all touched files according to the timestamp, and it includes the third-party files. So the third-party files will be removed as well. So once again, you cannot trust these heuristics procedures used by these installers and remove malicious uninstallers or malicious applications being installed with the purpose of touch to taint all files in the file system on purpose. So it's hard to trust in these applications removals to remove malicious applications. There's only one case in which we discover that's advantageous for a typical user to use these third-party removers instead of the native Windows uninstaller. That's basically when the installer application sets its uninstaller with the no remove option. That's basically a flag in the registry that signals to the system that that application should not be removed. The native Windows uninstaller respects that flag and does not remove these applications. But all the third-party removers basically ignore this flag, ignore the no remove registry key, and they are able to remove the application. So they have a greater power of removing applications in this specific case. So this might be another reason why users are migrating for this third-party application removal instead of using the native Windows application remover. But once again, talking more specifically about malicious removers and this kind of armored applications, what we discover is that the system architecture used by these removers not favor their self-protection. We discover that all these removers launch the removal capability, the removal process, the uninstaller process from their main process. It allows the child process, the installer process, to be aware of which process is its parent, what's the parent ID of the process that launched it. So if a malicious uninstaller is launched, the malicious uninstaller is able to know which process is launched the uninstallation process. And more than that, it is able to terminate the legitimate application removal. So the malicious uninstaller is able to finish the removal process and to finish its own application without removing the application. So if the uninstaller is malicious, these third-party removers will not be able to handle them, not be able to remove them if they are trying to kill its own process or kill its parent process to avoid the process to complete. More than that, we discovered that basically all these installers, when they search the file system, when they search the registry, they blindly trust the operating system. They assume that the operating system is reliable, it's providing meaningful information. But that's not the case when you are handling like malicious uninstaller and malicious applications installers, because they can the remover, they can provide information to deceive these applications. So basically, one malicious uninstaller could, for instance, inject a DLL, a library in the application remover to hook the APIs and to hide information. Or a malicious software could load a kernel driver in the system to hide some artifact, to hide some file system objects from the view of the removal process. And that's basically what we demonstrated with two implementations of rootkits, one at the user land, other at the kernel land. So basically what we did was to avoid the third-party remover to have information about a given application. And these third-party removers all fail to identify the application to remove them. So basically we're able to remove all the applications from the list of installed applications. So a user trying to remove a software would not see the software in the application list if the software is malicious, because the software has the opportunity to remove itself from the list of installed application by tampering with the software execution, by loading a kernel driver or a DLL to hide information from these third-party uninstallers. So third-party uninstallers are not a panacea for handling third-party application removal process. And that's basically our conclusions. So in summary, what we have to say is that there's no clear reason for using migrating from the native Windows uninstaller to a third-party uninstaller. A possible reason is that this third-party uninstaller have this better configuration possibility, this better user experience, a better user interface with more flexible configurations, but they definitely do not have a significantly greater removal capabilities. They have some heuristics that can be abused by third-party, by a malicious third-party entity. So they can be used to remove ordinary software. They basically work the same way that a native Windows uninstaller will operate, but they are not a substitute for any secured software, because they are not prepared with self-protection, with anti-tampering protection mechanism to handle malicious uninstaller. And due to this possibility of having malicious installers and uninstallers that make a mess in the file system on the purpose to probably crash the system operation to avoid being removed, that we have to develop better removal capabilities. So I think a promising way to move forward is in the future to study better mechanism to taint files that were touched by installers. So in the future, we can just remove these tainted files instead of having to analyze the system as a whole and facing the risk of touching third-party files that were not your original intention. So we have to worry about removers. That's often a neglected subject, but that deserves our attention due to this possibility of having malicious installers and malicious removers. Thanks. If you have a question, I'm open to answer them. If you want to chat with me later, please reach me out by email, on Twitter, or on my website. I'll be available. Thanks a lot for hearing me.